Today I went back to Radio Shack and got a radial capacitor to replace that axial capacitor. Smaller pins come out of the bottom instead of out of the axis of the capacitor. It's kind of stuck through the board there. I figured I'd build this up today. A little solder there. Okay. So I soldered it in and cut off the negative lead. Soldering's getting a little better. Then I soldered on the resistor by taking that positive lead that was already there on the capacitor and looping the resistor around it and pulling the capacitor wire back. And then I cut off the positive capacitor wire and the excess from the resistor. Oh my God, did I solder that resistor in backwards? Solder signal wire to the back and then cut off that excess back there. Looks pretty good. Not bad for government work. Put on the final ground. Put some shrink wrap on it. Nobody will ever even know that resistor is in there. Hook up the other end to the computer. I powered off the output rails and the signal off the sensor rail. Now we go back over to the mission planner. I'm going to test. I'm going to test the sonar. This is actually ultrasonics, guys. And there you see the signal from the sensor. As the sensor is moved, the number changes and basically in centimeters. It's about as complicated as that. I did not synchronize the changing of this data to the video of the sensor being moved around, dropped, whatever. Got a little problem with the pins just going down on the connectors. I got to put those inside another one so that they stay a little tighter. Got a little issue there with a little pin contact problem. I'm not going to solder them. Well, basically that's the way sonar works. Sonar, man, kills me. This is actually ultrasonics. It's going to be working from about 16 feet to 20 centimeters in increments of 1 centimeter. So now if we take a look at some of those numbers and some of the numbers I know about the equipment, that sonar, that ultrasonic sensor has a range supposedly of 7.65 meters, which is equal to roughly 301 3/16 inches. If we take the 301 inches and convert that to centimeters, we get 764.5 centimeters. That's roughly one of the high numbers I saw when I was playing with that. So it looks like basically that sensor's going to work to about 25 feet reliably. So I am going to go in and I am going to tell my programming to use the barometer above 20 feet and use this ultrasonic sensor at 20 feet down to 20 centimeters in increments of 1 centimeter. Now 1 centimeter is equal to 0.39 inches. 40% of an inch, not quite half. 2.5 centimeters. Almost an inch, 2.5 centimeters. So these, we're getting much smaller increments than if I were looking at 301 inches of travel that I can the computer can search for and try to achieve by centimeters. So 2.5 centimeters, if we convert that, 1 inch, I'm sorry, 1 inch, we convert that, we find it is 2.5 centimeters. I was close. But we have the 3999999, etc. on the end of it, which was my error. So at 20 feet, which is 20 times 12, must be 240. 240 inches. 609. Yeah, that's going to be close enough inside the sensor range to me to start playing with it. I may lower it a little bit due to the fact that if it's windy, the wind could blow the ultrasonics off course. So I think I got it. I'm going to start with somewhere between 16 and 20 feet. Tell you the truth, the RJU by default sets it at 60%, which is 16 feet. Later.